Every single time you send an email or stream a show or even just load a web page, you're tapping into one of the most incredible systems ever built by humans. But have you ever stopped to wonder how it actually works? Well, today we're pulling back the curtain on the invisible, high-speed delivery service that sends your data flying across the planet in the blink of an eye. So let's dive in. I mean, really think about it for a second. You hit send on a message here in, say, New York, and it just appears on a screen in Tokyo almost instantly. It's not magic, but it's got to be the next best thing, right? So how in the world does the internet pull off this incredible feat day in and day out? Okay, so the easiest way to wrap your head around all this digital wizardry is with an analogy we all get, the good old-fashioned postal service. And what's wild is just how closely the two systems line up. Just like a letter needs an address and an envelope to get sorted and shipped, your digital message gets chopped up into these little digital envelopes called packets. Each one gets a digital IP address, and then they're sent through sorting centers we call routers. Seriously, if you understand how mail works, you're already halfway there. All right, so let's start with the absolute most important piece of this whole puzzle, the address. Because just like a real letter, without a clear destination, your data would just be lost forever. This whole addressing system is managed by something called the network layer. You can pretty much think of it as the global headquarters for the entire internet postal service. And its one job, while it sounds simple, is absolutely massive: to make sure every single packet knows exactly where it's going, out of the billions and billions of possible destinations online. And what is that digital address? Well, it's the famous IP address. Every single device that's connected to the internet, your phone, your laptop, your smart TV, you name it, gets one. It's a totally unique identifier that basically tells the network, hey, over here, deliver the data to this exact spot. Without it, everything would just be chaos. And here's the really cool part. You don't even have to think about it. The moment you connect to a Wi-Fi network, a little system humming away in the background called DHCP automatically assigns a temporary IP address to your device. It's like walking into a giant post office and instantly being handed the key to your own personal mailbox, just for the time you're connected. It's all automatic. Okay, so our digital letters now have addresses. Great. But who's actually reading those addresses and directing the traffic? Well, that's where the tireless, unsung heroes of the internet come in. Meet the router. You've got a little one in your home, but the internet is literally built on millions of these things, from tiny boxes to giant machines that fill entire rooms. A router is basically a super smart, incredibly fast mail sorter. It doesn't care what's inside your data packet. Its one and only job is to look at the destination IP address and, bam, send it along the next step of its journey. And the way it does this is just mind-blowingly efficient. A packet comes in, the router just glances at the destination address, checks its internal map of the internet, and instantly fires that packet out the correct exit door toward the next router in the chain. It's a simple three-step dance: receive, check, forward. And this is repeated billions of times every single second all across the globe. And when I say fast, I mean fast doesn't even begin to cover it. A high-speed router has about 51.2 nanoseconds. That's billionths of a second to do that whole three-step process for one packet before the next one is already there. To give you some perspective, in the time it takes you to blink your eye, a single router could have processed millions of these packets. It's just incredible. So now that we've met the addressers and the mail sorters, let's actually follow a single data pocket on its epic split-second adventure across the internet. The journey kicks off the second you hit send. The very first hop for your data packet is a pretty short one. It just goes from your computer or your phone over to your home Wi-Fi router. Think of this as you dropping your letter off at the neighborhood post box on the corner. Now, your little home router knows it can't handle this trip alone, so it forwards the packet onto your internet service provider. Your Comcast, Verizon, or whoever you use. This is like your letter arriving at a massive regional sorting facility, where these huge industrial-strength routers are sorting mail from thousands and thousands of homes. From your ISP, your packet hits the superhighway. It jumps onto the internet backbone, this massive global web of fiber optic cables running under oceans and across entire continents. Along the way, it might hop between a dozen different routers in different cities, each one making a nanosecond decision to point it in the right direction. This is that network of networks we always hear about, right here in action. And finally, after its globe-trotting trip, the packet arrives at the local network it was looking for. The last router in the chain points it to the exact server, say a Google server answering your search, and poof, the journey's done. Now remember, your original message was actually split into tons of these packets, and they might have all taken different routes to get there before being perfectly stitched back together at the end. And this is where it gets really cool, because this isn't just some abstract concept. You can actually watch this happen yourself. There's a simple command built into most computers called traceroute. You can use it to see a list of every single router your packets bounce through to get to a website like, say, google.com. It turns this whole invisible journey into a real map you can see. So we've seen the addresses, we've seen the sorters, and we followed the journey. But, what's the big takeaway here? Why does understanding this invisible system actually matter? Well, it all boils down to a few really elegant ideas. First, the network layer gives every device a universal address, a common language they can all speak. Then you have routers, this decentralized army of super fast traffic cops that make sure nothing gets jammed up. And finally, the idea of breaking data into packets lets millions of us share the same digital highways at the same time without ever crashing into each other. This invisible foundation is what makes every single thing you do online possible. And the scale, the sheer scale this system operates on is just hard to comprehend. We're not talking about a postal service for a few million homes. We're talking about a system that seamlessly connects over 25 billion devices all around the world, and that number is going up every single second. Which brings us to a final, really interesting question. The people who first designed this system, they could have barely imagined connecting a few hundred computers. Today, we're connecting everything. Our cars, our watches, our coffee makers. As this Internet of Things explodes, how is this amazing global postal service going to have to change and evolve? What new challenges is it going to face? It's definitely something to think about.